This 2024 paper 1 question 7, and we're given some information here, and we have to find out the net annual pay. So we're told 20% on the first 40,000. So let's figure out what that is first. So if we do 0.2 multiplied by 40,000, that's going to be the first part. And then we have to do 40% on the remainder. So if we look, he earns 54,000. So if you take 40,000 away from that, that means there's 14,000. That's above 40,000. And on that 14,000, we have a rate of 40%. So we'll have 0.4 times 14,000. So you can just figure out what those are. So for the 20% of 40,000, we get 8,000. For the 40% of 14,000, we get 5,600. Add that together, and the total tax is 13,600. Now we have a tax credit as well, so that reduces how much tax you have to pay. So we can subtract from this 1,775, and what we'll get then is 1,1,825. So this is the total tax that's going to be charged. So we're looking for the net pay. So he earned 54,000 before tax. Take away that 11,825, and when you do that, you should get, and don't forget to put the euro sign, you should get 42,175 euros. For the next part, we have to write out the present value of 3 repayments. We're given some information. So there's a formula in the tables book for the present value, and here it is. So for the first month, we can it's going to be the final value, which we're told the monthly repayments are this much. So that's kind of what our final value is. So we have 1647.75. Obviously, there's a bit more understanding, but I'm not going to go down in detail. And we have 1 plus I, so it's important that the interest rate here, if you make that as a decimal, that'll be 0.00279 as a decimal, because 0.279%. So we divide that by 1 plus that number, so it'll be 1.00279. And then because it's the first month, we don't put it to any power. Well, we'd put it to the power of 1 for t, but obviously t is 1 because it's only been 1 month. Then for the second month, it's the exact same thing, except t will be 2, so this denominator will be squared. And then for the third month, we're going to have that same thing, except 3 months have passed, so that denominator will be cubed. Then we're told to find out how much they borrowed in total. Give your answer to the nearest euro. So you can do this with series if you want. A slightly faster way is to use the amortization formula. So we're looking for P here. The principal is kind of the final amount. So the annual repayment amount this is, but remember we're doing monthly. So the monthly repayment amount is this number. So it'll have 1647.75 equals the principal, which is what we're looking for, times the interest rate. Now remember, we're doing this all monthly, but it's okay. What we'll do is we'll convert the time to months, and then we'll use the monthly interest rate. Or you can convert the interest rate to annual, and then you could also use 25 years instead of putting it in months. So we'll have P times I. So I is going to be 0.00279. Then we're going to multiply that by 1 plus I, so 1.00279. to the power of the time, but remember that's in months, so it's 25 years and then 12 months in each year. When you do 25 times 12, you'll find that that is equal to 300, and then we can divide that by we'll have again 1.00279 to the power of 300 minus 1. Then to get P by itself, we can just rearrange. So basically what we're going to do is we're going to take this and we're going to multiply both sides by this, so it'll cancel on this side, and then on the left-hand side, we're going to be multiplied by this number. So basically, we're going to have this, and we're going to multiply by this denominator, just brought it up to the left-hand side, and then we can divide both sides by this thing, and then on this side, it'll cancel out, and on this side, it'll come over to the denominator, and that leaves us with P by itself, and you can just put that into your calculator, and what you should get for P when you do that is euro 334.562.61, and it says to the nearest euro, so it's important that you put your answer as 334.563, because we're going to round up because it's 61 cents, and that is the answer. So then we're given an equation for savings this time, and we're told to find the rate at which the amount of money in the account is increasing after 3.5 years. So t is in years here, so that's cool. So you're using differentiation, so let's differentiate. So we'll have f prime of t will be equal to, so remember when we're differentiating an exponent, we kind of have a function inside of a function. So we have this thing in the power, putting it in the power is one function, and then we have an inside function, which is taking the t and multiplying it by 0.04. If that's too complicated, there is a formula in the log tables for how to differentiate something that looks like this, but I prefer explaining it using the chain rule. So that 5,000 is a constant, that stays out the front. And then we'll do the outside function. So the derivative of the outside, well, I think it's most people might actually do the inside first. So the derivative of the inside function, so the inside is what's inside this power. So 0.04 is the derivative of 0.04t. So we'll multiply by that. And then we do the derivative of e to the power of something is just going to be e to the power of that thing unchanged. And that's our value. That's what f prime of t is. So then to find f prime of 3.5, we just replace all the t's with a 3.5. So we'll have 5,000 times 0.04 times e to the power of 0.04 times 3.5. And you can just put that into the calculator. And you'll get 230. So we get 230.05. It says the nearest euro per year. So that'll be equal to 230 euros per year. If you want to put in the units just to be sure, but they are not too strict about that. Then we're told to use integration to find the average value for the first 5 years. So there is a nice visual reason for why this formula works, but for the interest of time, because this is just a solutions video, I'll just say that the formula for the average value is 1 over b minus a multiplied by the integral between a and b of whatever the function is, in this case f of t with respect to t. So how are we going to do that? Well, our limits are going to be b is going to be 5 and a is going to be 0 because it's the first 5 years. So if 1 over 5 minus 0 is just 5, times the integral between 0 and 5, and then we're going to have 5,000 e to the 0.04t with respect to t. So basically what we can do is we can take that 5,000 to the outside because it's a constant multiple. You might not do it this way, but it's kind of the same either way. It just makes the inside a little easier to deal with, so 0.04t dt. Then when we integrate it, we kind of have another chain rule thing going on. So I'm going to have this 1,000, and then we're going to have the integral of e to the whatever is just going to be e to the power of that thing. But then for differentiation, we multiply by the derivative of the inside function. For something like this, we divide by that derivative because it's integration. If you don't like memorizing that, or if you don't understand, there is a formula in the tables book as well that might make it easier to remember. But this is what you get. And again, you could check that. If you differentiate this, you'll end up multiplying by this thing, and then it cancels out with that, and we're left with what we originally started with. And then we're evaluating that between 5 and 0. So basically what we're going to get is 1,000 multiplied by, we're going to have e to the power of 0.04 times 5 minus e to the power of 0. It's all going to be over 0.04. And you can just put that into your calculator. And you'll get 5535.06. And then to the nearest euro, it says we round down because it's a number less than a half. So we'll have I keep putting the comma there, 5535 as our final answer. Then we're told to find the annual interest rate. An easy way of thinking about it is just the percentage increase in the account over the course of 1 year. So basically, a way we could do this is we could look at f of 0, and we could look at f of 1, and we could find the percentage increase over this time. So what will f of 0 be? Well, f of 0 will be 5,000, because it'll be 5,000 times e to the 0 is just 1. So f of 0 is equal to 5,000. And f of 1 will just be equal to 5,000 times e to the 0.04 times 1. So we'll just have 5,000 e to the 0.04. So let's see how much it increased by. Well, basically how much it increased by as a percentage, we divide the two things. So the bigger thing, well, I suppose the thing later in time is the proper way to think about it, divided by the thing earlier in time. The 5,000s cancel. We find that the growth rate is e to the power of 0.04. And if you put that into your calculator, you should get something like this. So the reason there's a 1 here is because basically the 1 is the original, and then how much it changed by is 0.04081. So basically it's the same as 1 plus, and then convert this to a percentage, you'll get 4.081% is essentially what's happening. And then we're told 2 decimal places, so we can just say 1 plus, it's going to be 4.08% as our final answer.